Yeah, so equations of a tangent to a circle. So for this content, there's nothing that I can teach you in terms of theory, right? But there's a lot I'm gonna teach you when it comes to application. So yes. So what I am going to do, what I'm going to do is we're gonna jump in some examples. Yeah, we're already gonna start doing examples to see how to deal with the idea of the tangent being brought in a circle. So, and I think it doesn't really matter. You can have a circle with center 0, 0, or you can have a circle with a center as AB, and yeah, they can still ask you about the tangent or the equation of the tangent, right? Well, let's cook. Let's cook. One thing we have to understand before we continue, when you have your circle, perfect circle, and you have your Cartesian plane, right? And there is a tangent. Cool. Let me. So you see this tangent, perhaps I can color it differently. This tangent, it is passing through the circle at one point, which is so it has touched our circle right here, and yeah, right. And say right here you have your center. Let me see, where can I put it? Right here. Now, so if I draw a straight line, if I draw a straight line from the my god, if I draw a straight line from the center of the circle to the circumference where the tangent is, so I draw my radius, and my radius is of course from the center to the circumference, but at the tangent here, which is say this is point P. What's gonna happen is that of course, my tangent and my radius will always be perpendicular, right? So that's something that you guys must know for this this thing. I think in Euclidean geometry you guys did that, right? Yeah, there's this fact in Euclidean geometry. But let's now cook, so of course from this scenario you are where you need the what? You're gonna need the the center, and you already have the point there, minus 2 and 5, right? So we have our point there, which is minus 2 and 5. So what we then try to find is the center, and to find the center we're gonna have to complete a square. You have x squared plus 6x. Yes, I man, 2y, say minus 7. We can just leave it there until, yeah. So you have, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Cool. So here you have x squared plus 6x. I take 6 divided by 2, I get 3. Now I'm gonna write plus 3 squared minus 3 squared. Then I say plus y, we have y squared minus 2y. I take 2 divided by 2, I get 1. So I'm saying plus 1 squared minus 1 squared. It seems like that's the end of it. That is the end of it. So we have all of these, and then we're going to have a minus 7 equals to 0. Then you group the first three, so therefore here you have x plus, remember the sign here is plus, so it's x plus 3 squared minus 9 plus, here it's gonna be y, the sign is negative, minus 1 squared minus 1 minus 7. Cool. Well, that means you have minus 10 minus 17, so you have 17 this side. Ouch. You have x plus 3 squared plus y minus 1 squared, and that means the center, so therefore the center is gonna be x, which is minus 3, and y, which is 1. Yeah, I was quite close with my diagram, ne? Quite close. Perhaps if I just put it somewhere here and say this is the center. But yeah, so now I have the center, ne? And I know that a straight line, a radius, ne? My radius is perpendicular to the tangent. So, and I know the if I have two lines, ne? Line AB and line DF, I know for sure that these two lines are perpendicular if the product of the gradient of the two lines gives me minus 1. So I can find the gradient of the radius. After finding the gradient of the radius, I say gradient of the radius multiplied by gradient of the tangent must be minus 1. From that, I find the radius of the tangent. After finding the radius of the tangent, I am basically done. Right? Basically, I am done. So let me do that. So we have this point and we have point F, which is what? Which is minus 2 minus 2 and 5. Minus 2 and 5. So I can then say gradient of the radius is gonna be, of course I have change in y. Let me just say y2 minus y1, x2 minus x1, which is say 5 minus 1 all over minus 2 minus 3. That's gonna be 4 over minus 2. This is minus 2, of course. Then I have a 3 here, so this 3 is a positive 3, so I have 1, so I have 4, right? And then I say the gradient of the radius multiplied by the gradient of the tangent must give me minus 1. And then here I have 4 multiplied by mt the Hassler minus 1. Therefore mt equals to minus 1 over 4. Right, so I found the gradient of my tangent. Now I can I'll remove all this. Now I will remind you something very important. Remember, equation is that you have the formula for the equation of a straight line, which is y minus y1 equals to m, which is the gradient, into x minus x1. Right, so that is a formula of a straight line. Right, from now what happens? Remember, you have point F, which is minus 2 and 5. Minus 2 and 5. Ne? So we substitute everything. Y minus 5. So that is okay. We have a 5, so y minus 5. Gradient, which is minus 1 over 4 into x minus 2. Alright, so you're going to have y equals to minus 1 over 4, x plus 2 plus 5. Right, you multiply here, you have 1 over 4x. 1 over 4x. You multiply, you have a minus 1 over 2 plus 5. And therefore your equation for this will be 4.5. So how do I write that? Let me just say plus 4.5. How do I write 4.5? 8. 9 over 2. Yeah, 9 over 2. So by this, bro, you have found your equation of your straight line. Oh no, yes, you have found the equation of a straight line, which is the equation of the tangent, right? And this is the equation of the tangent, right? Cool stuffs, cool stuffs, cool stuffs. Good. Cool. So listen to what they are saying. They say you have a straight line. There is the equation, né? And it cuts the circle, this circle. So before we go deeper, you look at the circle, you're like, the center is what? Is the origin. You see, by the structure of the equation, you can clearly see, this one, right? The structure looks like the structure of a circle where, where 0, 0 is the center. So, I calculate the coordinates of P. Ne? So look, and these two equations, you have this equation and this equation. They say the straight line, it cuts the circle. So therefore, because they cut, therefore they, at that point where they cut, they will have the same x value and the same y values. So as a result, we're going to sub the straight line equation into circle equation, or you can just say the straight line equation is equation 1 and this circle equation is equation 2. Then later on you say substitute 1 into 2, right? So after, when you substitute, you will have x squared plus open bracket x plus 4 squared then equals to 26. All right, so we expand this. That is x squared, that is a 4, that is 8. You have 8x plus 16 equals to 26, and therefore you have 2x squared plus 8x, and then plus 16 minus 26 equals to 0. 2x squared, 8x. This will be minus 10. 16 minus 26, minus 10, 0. And then divide by 2, you have x squared plus 4x minus 5 equals 0. And now the question is, okay, to factorize this, you're going to have x plus 5, x minus 1 equals to 0, and therefore x equals to minus 5, or x equals to 1, right? And then for this one, remember you have y equals to x plus 4, so you will therefore say y is equals to minus 5 plus 4, which is minus 1, and then here therefore y equals to 1 plus 4, which is 5, and therefore you have your points, which is minus 5 and minus 1. You have your point as 1 and 5, right? So these are your points, right, where the graph, where the graph intersects with the others. Let's see if there's anything that can help us identify which one is which. I mean, we might as well just leave them like this, because we can't really say for sure what is P and what is Q. Yeah, ne? So then they say sketch the circle and the straight line on the same axis, label P and Q. Alright, cool. So we need to, I'm gonna call this P, I'm gonna call this Q, right? And yeah, So we have to draw our circle. Delete. Cool. We have our beautiful circle there and a straight line. Y equals to x plus 4. So I'm gonna have a 4 here. Oh, I see what's happening. We're gonna have a 4 here and minus 4. So we have a straight line here. Cool. Y equals to, then there's the circle. Yeah, there's the circle. X squared plus y squared equals to 26. And this point 1 and 5, 1 and 5, that is a Q, and here we have P, which is what? Minus 5 minus 1, right? And then they say determine if the coordinates, or determine the coordinates of H, which is the midpoint of a chord PQ. So to determine the coordinates of H, remember, this is the, not midpoint theorem, but the midpoint of a straight line. So you're going to have H, right, X, Y, being what? Being, you have x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? And you're going to have x1, that is minus 5 plus 1 divided by 2. We have minus 1 plus 5 divided by 2. Right, so you're getting minus 4 here. Yeah, it's gonna be minus 4 and then minus 2. It's gonna be 4 and 2. So the point there is what? The point there is 2 2 minus 2 2, right? So this is what? This is H. And so I can put it here and say here we have H, which is minus 2 2. Let's see. If O is the center of the circle, right, show that PQ and OH are perpendicular. Right, here's O. Right, here's O. And they're saying show that we must show that PQ and O are perpendicular. Yeah, sounds better, looks better. So how do we do that? Let me see. So look, the thing is we have the point for the center, which is 0 0, and we have this point. With them we can find a gradient of this line, right? And we already have the gradient of this line. And so let's find the gradient of HO. Gradient of HO, of course, you have y2 minus y1 over x2 minus x1, which is gonna be y2, that is a 2 minus 0 over minus 2 minus 0, which is minus 1. And then gradient of HO multiplied by gradient of PQ, right, is equals to minus 1 multiplied by the gradient of PQ, here it is, which is 1. So 1, and you're getting minus 1, and therefore HO is perpendicular to PQ, right? Let's see the next question. Determine if the equations. Determine the equation of the tangent at to the point, right? Cool. So of course, now if you want to determine the equation of the tangent at a point, right? Yeah, so I'm gonna just choose randomly whether I do P or Q. You can do the rest, the other, right? So because the how you work out this question is basically the same. So yeah, I don't want to make the video unnecessarily long. So you know how you are going to do that. You're gonna find the gradient from the origin to one point, deciding depending on the point you decided to choose. I'm gonna choose Q, right? So I'm gonna choose Q, and therefore if I'm choosing Q, we are talking about OQ, right? That straight line. So in a sense, I have my tangent right there, right, which is perpendicular to my radius, no? So I'm gonna find the gradient of OQ, right? And then because I know that they are perpendicular, you know the drill, bro. You know the drill, right? So okay, gradient of OQ is y2 minus y1 over x2 minus x1, which is what is it? Okay, I have my points over there, so I have 5 minus 0 over 1 minus 0, which is 5. That means, and it makes sense. Yeah, does it make sense? Wait. So minus 0 divided by minus 0, which is, the thing is, does it make sense? Right? Because this is like this. As x values, yes, it makes sense, because as x values increases, the y values also increases. That's what I mean when I say it doesn't make sense. I was trying to confirm that, you see. So yeah, now I'm gonna say therefore I'm gonna say the gradient of OQ multiplied by the gradient of the tangent equals to minus 1. So 5 multiplied by mt, the hustler, and therefore mt equals to minus 1 over 5. And then I go and I say y minus y1 equals to m into x minus x1. Then I substitute. I have 1. The y value is, I think, wow, no, minus 5. It is minus 5. Yes. And then I have equals to minus 1 over 5 into x minus 1. I have y minus 1 over 5 plus 1 over 5 plus 5. So y is going to be, I forgot the x. And wait, so what am I gonna get? 26 over 5. Is that so, bro? 1 over 5 plus 5. Yo, 26 over 5. So that is the equation of the tangent. That is the equation of the tangent. So now I'm gonna say this. For P, if you choose P, it's very basic also. You find the gradient of OP, right? And of course you know that so this is OP. So this is OP, right? this is OP. And then you know there will be a tangent passing through OP, which is perpendicular to the radius OP. And then you find the gradient of OQ. After finding the gradient of OQ, you then say the gradient of OQ times the gradient of the tangent is -1. That helps you to find the gradient of the tangent. After the gradient of the tangent, you come here. From here, you substitute. Eventually you get your answers. And I'm telling you, bro, it's literally the same. So they say determine the coordinates of S. S is the point where the two tangents intersect. So now look here, I'm forced to actually bro, I thought I was actually gonna avoid this. It's cool. Hey, it's not cool, man. It's not cool. But let's do it. So gradient of OP is gonna be, so here OP, I'm gonna have -1 minus 0 over -5 minus 0, which is 1 over 5. And therefore gradient of OP times gradient of the tangent. So this one I'm just gonna be quite fast. -1. And so 1 over 5 times mt equals to -5, and therefore mt equals to -5. And then I have y minus, now I'm substituting my point. The y value here is -1, right? Gradient to -5, I have x minus -5, right? So that means I have y plus 1 equals to -5, x plus 5, and then this is going to be y minus 5x minus 25 minus 1 minus 5x minus 26. Right, so you see now what I have found, you know? So that means, what's the next thing? The next thing is going to be me finding wait. Okay, so the next thing now, I have to find, remember I am looking for the point where the two intersect, and the question is, where is that point? I'm going to therefore equate the two equations to each other. After equating the two equations to each other, then voila, right? I would have found my yebo. So I'll just delete this. Delete. Take my equations up high. So I will say y equals to y, which is minus 5x minus 26 equals to minus 1 over 5x plus 26 over 5. Now, okay, let me take the minus 5 that side. So I have 5x minus 1 over 5x. Then I have 26 minus 26 minus 26 over 5. And that means this side I have 25. So this side I have 24 over 5x. And this side I have minus 26 over 5. So I have minus 156 over 5. Multiply by 5. I'm getting minus 156 equals to 24x. 24x, and therefore x is going to be So it's going to be a negative 156 divided by 24. That is 13 over 2. So I have negative 13 over 2. And then I say y equals to minus 5 minus 26, 5x. So therefore y is going to be minus 5 into minus 13 over 2 minus 26. Yeah, minus 26. So I say minus 5 into minus 13 over 2 minus 13 over 2 close bracket. So minus 5 into minus 13 over 2 minus 26. I get 13 over 2. So that means that point in a point S is minus 13 over 2 over 13 over 2, right? And yeah, then this question they say show that S, right, what is 13 over 2 is 6. So therefore okay, so the point is gonna be perhaps somewhere because okay, so this tangent, okay, so remember that this tangent line continues, and of course this tangent line continues. So apparently here at this point, that point, so that point is going to be point S, which is minus 13 over 2 and 13 over 2. So now they say show that S, this point H, here's H and O, they are on a straight line. So of course my diagram is not drawn right up to scale, because you see now I have O here, I have H, and then S is there, so it won't look like a straight line, especially here it goes like this and there, so but we have to prove that it's on a straight line. And how we will do this is so basically you try to find the gradient. Okay, let me do it. Let me do it. So basically you're gonna find the gradient. You can find, let's start finding the gradient for SH, right? Then we find the gradient for SO, and then we find the gradient for OH, right? Ouch. And I think the gradient for OH, we did find it. We did find the gradient for OH. I don't know. Oh, when we were proving that, it was, which question? When we were proving number 4, we were proving that OH and PQ, they are perpendicular. So when we found out that the gradient here, gradient of OH, it was minus 1. So I can find the gradient of, let me find S. So MSO is going to be y2 minus y1 over x2 minus x1, which is what? Which is y value is 13, a positive 13. So I have 13 over 2 minus 0, and then over minus 13 over 2 minus 0. So this 0, of course, they are gone, and then we have the same thing dividing. It's going to be negative 1, which already this negative 1 matches this negative 1. So now let's quickly find MSH, right? You have y2 minus y1, x2 minus x1. Oh, that looks like a pie. Then what do we have? So we have 13 over 2 minus h minus 2. Is it positive? Let me see. Yes, it is positive. So 13 over 2 minus 2, and then minus 13 over 2 minus 2. Right, I am going to get calculator, 13 over 2 minus 2, and then I have minus 13 over 2 minus 2. Right, and I am getting minus 1. So now you see that the gradient of these things, they are the same, right? And therefore that must mean that H, S, and O are on the straight line, right? Yeah, they are on the straight line, right? Or you can just say that the what can I say? Yeah, they are all on the straight line, right? And if perhaps you can also find that straight line, right, you can do some workings to find a straight line. You'll find it to be y equals to minus x, because basically look at it, né? We have 0 0, right? Y equals to minus x, and then we have h, né? If x is minus 2, then that one is going to be a positive value because of the minus. We say y equals to minus x. We go here as well, we have minus 13 over 2, 13 over 2. So yeah, the equation of the line there is y equals to minus x. Guys, let me end it here and let's do some exam questions. Away.